Okay, this is the review for exam 1, and I would like to start this review by giving you some exam taking tips. So the first one that I always recommend to my students is number 1, read carefully. Sometimes you are in a rush, and I understand this is a race against time, but you need sometimes to just slow down a little bit so that you read the problem correctly and get all the information that you need to answer. Particularly things that you have to be kind of cautious is sometimes you will find a question that asks for what is the true statement. And our brains usually are wired, they are naturally wired to find the true statement. I mean, it's a given. You always think in terms of what's true. But sometimes we are looking for the false statement, and sometimes people forget about that. Pretty much the same thing. Sometimes is or is not. So pay attention to those instructions there. Okay, what is that they are really asking? Do not get confused. It's very easy to get confused here. So you will get even more confused if you don't read carefully. Okay? So that's it. True, false, is not. Try to find those. The second one, it also goes in the way of reading carefully, but it's also pay attention to instructions. And this goes, I have said this in class, but this goes with fill in the blank questions. Okay? Significant figures. Are you restricted by significant figures? Sometimes it's not about significant figures, but it's about decimal points. Yes. Almost always, if it's a numerical value, you are not to put units. And sometimes you have to pay attention to significant figures, decimal points, no units. Sometimes you also have to significant figures, decimal points, no units, and this is a fill in the blank. Oh, sometimes you also have to pay attention to whether you are supposed to use scientific notation or not. There are some questions in which specifically says do not use scientific notation. So pay attention to those. Now this is the most important one. Number 3. Do not get stuck. It's a race against time. Time is precious here. Do not get stuck. Okay? Trust me, you know enough, or you have studied enough that you have a pretty good idea of what you know and what you don't. Okay? So do not struggle with any question that you can't figure it out. Just move on. Okay? You want to save as much time as you can down the road, so do not get stuck. So if you can't figure it out what to do in less than 30 seconds, then move on. If you have time, then you go back to the question. But if you don't have time, you are just missing one point. Do not struggle more than necessary in one single question, because I can guarantee you that down the road, that to the last questions in the exam, there might be some that are easier than that one that you are getting stuck on. Okay? So try to guarantee the easy points first. And that is if you move on quickly. Okay, now let's go to the exam, right? So this is exam 1 from spring 2019 because it represents better what we are covering. So the first question is, molecules can be described as, and molecules, simply put, molecules are compounds. Weak compounds in turn are pure substances. And as such, pure substances, if you remember, they are not mixtures. Okay? In mixtures can change composition without changing chemical identity. But compounds, our pure substances, cannot do that. Okay, so remember this. Chemical ID. Okay, so you have molecules, compounds, pure substances, nothing to do with mixtures. So you can forget about A, you can forget about B, you can forget about D and E. It's two or more atoms chemical joining together. Now the statement, in a chemical reaction, matter is neither created nor destroyed. Well, that's more related to the law of mass conservation. Why? Because it's referring just to matter as in general. Okay? If it was saying about atoms, then you would say that's Dalton's atomic theory. Okay? And multiple proportions, remember that whole number ratio for different compounds, and this is basically constant composition when two or more elements react to produce the same compound. Okay? That's the law of definite proportions. Properties of a liquid. So remember, we have solid, liquid, and gas. When it comes to shape and volume, the solid is definite shape and definite volume. The liquid is definite volume, the volume doesn't change, but the shape is variable. And for the gas is both variable shape, variable volume. And for the gas, for the variable volume, okay, the gas, the key concept here is that for a gas you can change the volume of the gas without changing the amount of gas, meaning you don't have to add more atoms of the gas to change the volume. That can remain constant and you can change the volume. For the liquid, not so much. You can change the volume of a liquid, but in order to do so you have to add more liquid. So that's the difference here. Okay, so in this case, if we are looking for properties of a liquid, it has definite volume. Okay, it's here, definite volume. No definite volume, that's not it. No definite volume, that's not it. Okay, but have variable shape or not definite shape, so the answer is B. Physical change, remember, can return by physical means, return to initial state. Okay, iron rusting, not by physical means. Sugar heated to make caramel, you cannot convert the caramel back to sugar by physical means. The glucose being converted into energy within your cells, well, when do you digest the glucose and you get energy out of it? It's not like you can go back just by physical means, so the glucose is gone. And water evaporating, this is liquid to gas, which in return the gas can go back to the liquid, so you haven't changed the chemical identity in that process, so you can go back. So the answer here is D. Okay, what is the volume of an object with a mass of 455.6 grams and the density is 19.3? Three significant figures, so all there is to this is density equals mass over volume, and then it's just 455.6 grams. Oh, and we are calculating the volume, so basically you just switch those two places. It's mass over density, so the mass is 455.6 grams and the density is 19.3 grams over cubic centimeter, which is equal to a milliliter. So this is equal to 23.59 grams. Because you are to report with three significant figures, your answer has to be 23.6. And this is a favorite of everyone. So first step, you have to solve the top part. So 249,362 plus 41, this is 290,362. You have to ditch all of this because you don't have decimal points here, but this 0 here is significant. Okay, so what you get out of this is 290 point, and then you divide that by 63.498. So this is 3 sig figs, this is 5, so you keep the 3, so the answer has to be B. Watch which length is the shortest. Well, technically you have to convert these to probably the same distance, so to speak, so you can pick what the smallest one is. So let's say inches, so this times 12, this is 36 inches, so you have 57 here. Yards, you have 1.5 yards times 3 feet per yard times 12 inches per feet, and that's 36 times 1.5, 54. So right now this is winning, 36. And 1.5 meters is more than 1.5 yards, so a meter is slightly longer than a yard, so therefore the shortest distance is 3 feet. Which one is a chemical change? Chemical change, you know, something that implies change in composition. Okay, change in composition. Dry ice sublimes. Well, dry ice is CO2. If it sublimes, it's just CO2 in the form of gas, so that's physical. Charcoal burns. So yeah, you start with the charcoal and then you end up with ashes. That's a chemical change. Okay, so the answer is here because it's just one. Just by the fact that there is some physical change in the first option, then you cannot say that all of the above are examples of chemical changes. Intensive property. Intensive property does not change with amount of matter. Okay, the height will change with amount of matter. It's basically length. The volume will also change with amount of matter, but the boiling point, it doesn't matter if you have 1 ml of water or you have 10 gallons of water. If you are heating the water to evaporate it, they all will boil at the same point, 100 degrees. So the answer is A. Melting point of molybdenum is 2623, and we want to know what the temperature in Kelvin is. So Kelvin is Celsius plus 273. Therefore, we are looking at 2623 plus 273 which is 2896, and that's your answer. How many significant figures are in the measurement? So you have a decimal point and leading zeros or zeros to the left are non-significant. Okay, so this is not significant, this is not significant, this is not significant. So you end up with 4. Now be cautious, because one other thing that I can ask here is how many zeros are significant. And you have a total of 5 zeros. 5 total zeros. Only 2 significant. Which are those 2. So pay attention. Pay attention to that kind of thing. This is about differentiating between exact measurements or exact numbers and different measurements. We are looking for the one with 2 significant figures. If it's a number, remember, exact number is infinite significant figures. Okay, so there are 12 eggs in a dozen. This is counting, so therefore it is an exact number and have infinite number of significant figures. That's not what we're looking for. A day is marked by 24 hours. This is 1 day equal 24 hours. This is a definition. It's an exact number. So that's not it. The mass of your friend is 65 kilograms. So how do you know that? Because you measure it, and there is some uncertainty there. So if you report 65, you're not caring about everything else after the 5. So this is actually the number that has 2 significant figures. A student determines the density of a sugar solution, and the results are this: 170, 173, 166, 178. The true value for the density of sugar is 140. Yeah, okay. What do you do here? Or how would you approach this? Okay, what is the largest value that this person obtained in this experiment? The largest value is 173. What is the smallest value that the student determined? That is 166. So what's the difference here? 173 minus 166. This is 0.07. Okay. Now, what is the smallest difference between those values? You can also approach with the average, but it's not necessary. So the smallest difference would be between this one and the actual value. So it's going to be 166 minus 140. And that is 1.26. So you see that this difference is smaller than the difference between the lowest value and the actual value. So the values are actually farther away from the actual value than they are from each other. So these results are precise, but you are not that close compared to how close the measurements are, but they are not accurate. Okay, they are not accurate. And well, if this difference was larger, then I would say neither precise, but it's not the case. Okay, so the difference between measurements is smaller than the difference with the actual value, and that's why the measurements are precise but not accurate. Okay, this is from now on, I think it's basically dimensional analysis. So I'm just gonna propose and then you get the answer. In this case, you have to be able to extract information out of the problem, correct? So here, this is the extract information. What you're looking for is this. So 1 liter equals 2 miles. That's the first conversion that you need. How many liters is required for a person to walk 15 kilometers? That's data. You have miles, you have kilometers. The one that you need to know is that 1 mile is 1.609 kilometers. Yeah, and then you put everything together and then you're good to go. So you start with 15 kilometers because you have miles there. Then you have to convert to miles, right? 1 mile is 1.609 kilometers. This cancel. And then 1 liter of water is used per every 2 miles. This takes care of the miles, and then you obtain your result in liters. You do the math. If the walls of the room are 955 square feet and a gallon paint covers 15 square yards, how many gallons are needed to paint the room? Okay, there is the conversion factor that you have here. You usually start with a unit that is not a ratio, so we actually start with 955 square feet. And what you have to do, this is units raised to a power, so you are to eliminate the feet, 3 feet down here and 1 yard down here, and all you have to do is square this. Okay, that will take care of what you need. And then last but not least, you have 1 gallon per 15 square yards. Now the most common mistake that I see here is that people tend to do this. You have your feet square here, and then you have 1 square yard. Because of the 1, they tend to put just 3 square feet, but people forget that you actually have to put the 2 there. It's 9 actually. This becomes 9. That's what most of the people forget to do. And then 1 gallon, 15 square yards, and you can do the math. Same thing here. Okay, how do you extract information out of this? You have 1 pound equals this many grams. You have this. If we transform this, 6 milligrams of drug are equal to 1 kilogram of body. They are units of mass, but they don't cancel each other because they are referring to different things. So that's what the conversion factor actually tells you. So you're starting with the weight, 115 pounds. So you can convert that to grams, 453.59 grams per pound. You have kilograms of body, so you have to take that to kilograms. So 1 kilogram is 10 to the negative 1,000 grams. And then you require 6 milligrams of the drug per kilogram of body. So this cancel with this, this cancel with this, this cancel with this, and then you do this operation here and you obtain what the mass in milligrams is. Okay, in this one, office heater emits 2050 BTU of energy per hour. So 2050 BTU equals 1 hour. If it operates constantly for a year, then 1 year is 365 days and 1 day is 24 hours. And how much energy is released? And here you have an additional conversion factor that takes BTU to 10 to the BTU to kilojoules. Okay, however, this is kilojoules and you have megajoules here, so you have to be careful with that. So 1 kilojoule is 1000 joules. 1 megajoule is 1 billion 1 million joules. Okay, so we have 250 BTU 1 hour times 24 hour a day times 365 days a year, this cancel with this cancel with this, times, here we are converting BTUs to kilojoules, to joules, or yes, to kilojoules, 1.055 kilojoules per BTU times, and I'm gonna do it this way. It's a little longer, but I think it goes more towards the point. 10 to the power of 3 joules per kilojoule, and then 1 megajoule is 10 to the power of 6 joules. So you cancel joules here, you cancel kilojoules there, and BTU cancel with this BTU. You finish the calculation and I give you the number. So now hybrid car has a rating of 45 miles per gallon. If the round trip is 277 miles, how many gallons of gasoline will be used? So this is actually should be pretty simple, but you know. So you have 277 miles, that's the distance of the trip, and we multiply that by 1 gallon, which is how much you use per every 45 miles. These two cancel, and it's basically dividing 277 by 45. That gives you the answer. Now, cubic centimeter. Cubic centimeter is a unit of what? Cubic centimeter is, the centimeter is a unit of length. When you measure it 3 times, technically you are measuring the volume. So the first option here is volume, and 1 cubic centimeter is equal to 1 milliliter. So therefore the answer here is 1. So the blanks here, blank number 1 is volume, blank number 2 is 1. Meaning here 10 to the negative 2, 10 to the negative 2 is centi, 10 to the negative 9 is nano, the symbol for centi is C, lowercase c, the symbol for nano is N. So blank number 1, the name is centi, blank number 2, the symbol for centi is lowercase c, then we have nano, and then we have N. Now we are covering a little more material in this exam, so we go into exam 2 actually. We already discussed this, but how would you recognize that the law of definite proportions is in place? So a sample of chlorine is found to contain 3 times as much chlorine 35 than chlorine 37, but its law of definite proportions, it implies 2 different elements reacting. Okay, so this is just one. 2 different compounds. Now, law of definite proportions refers to the same compound. Okay, so this is not it. Now, 2 different samples of table salt refers to the same compound, are found to have the same ratio of sodium to chlorine. Okay, so this is actually the answer, because the next one says the atomic mass of bromine is found to be 79.90. So that's similar to the first one. This has to do with isotopes, and isotopes do not qualify for law of definite proportions in that sense. So different isotopes just have different masses, but you are not implying a reaction there. Okay, so law of definite proportions implies that there is a chemical reaction. Law of conservation of matter. In the previous case it was, I give you the statement, you identify that as the law of conservation of mass. Here, law of conservation of mass is everything to do with a chemical reaction, and you don't create matter, you don't destroy matter. So is number A. How the cathode rays direction was manipulated. Okay, they use electric and magnetic fields, and that those rays were bending depending on what direction, what charge was being approached. They deflected towards the positive charge, deflected toward the North Pole. So here is A. It wasn't about turning, it wasn't about using mirrors, and it wasn't about UV rays. What was surprising to Rutherford is his core experiment. The atom split apart when hitting the foil. Actually, that didn't happen. The particles began to wear down the foil as they hit it. That was not observed. The foil began to change colors as particles passed through. That also was not observed. It was the fact that some particles were bouncing back. That was the most striking observation. Why was the mass ratio of hydrogen to helium not 1:2? Because helium has, this is 1 proton, helium is 2 protons, so if there were only protons there, the mass ratio should be 2:1 when you look at helium and hydrogen, but it was 4. So instead of the helium atom to be twice as heavy as the hydrogen atom, it was 4 times. So we know now that that's because of the neutrons. So at that point when they were measuring that, they didn't know that the neutrons were around there. Which statement about subatomic particles is true? Okay, remember, true. What is true here? A neutral atom contains the same number of protons and electrons. Yeah, that's it. Well, let's check the other ones, why they are not. Protons have about the same mass as electrons. Electrons are tiny. Okay, basically we don't consider the mass of the electron. Electrons make up the most of the mass of the atom. If they are tiny, if they are not as nearly heavy as the protons, then that is nope. That doesn't happen. Protons and neutrons have opposite charges. Neutrons are neutral. That's why we call it neutrons. So this is not true. Which statement about isotopes is true? Isotopes of the same element differ only in the number of electrons they contain. Well, now so much. If they differ only in the number of electrons, we might be talking about ions. So this is not it. Isotopes of the same element have the same mass. Actually, no. They have same number of protons. Some elements have 3 or more naturally occurring isotopes. That's actually yes. There are some that is just 1. There are some that are 2. There are some that are 3 or more. I think molybdenum, I have like 7 stable isotopes. Isotopes of the same element have the same number of neutrons. Actually, no. Same number of protons, yes. Same number of neutrons, no. They actually have that different number of neutrons because they have different masses. Mass number. Remember, that's a counting number. What are you counting? You are counting the number of particles in the nucleus. And what you have in the nucleus? You have the protons plus the neutrons. Okay, so that's what the mass number is telling you. So number of electrons and protons, nope. Number of protons, no, that is the atomic number. Okay, so these two are incorrect. The sum of number of protons, neutrons, and electrons. We take this and we'll be good, but no, it's not it. So it's the sum of the number of protons and neutrons. Now, what does X is here in this symbol? Remember, X is the symbol. The 14 here is the atomic number. And the 28 here is the mass number. The atomic number defines the atom, so the atomic number is equal to 14, and when you look in the periodic table, that is silicon. So your answer here is silicon. Calculate the mass of element X if you have two naturally occurring isotopes with the following masses and abundances. Remember, we take these two fractionals, so this is 0.3288 and this is 0.712. So X is going to be equal to 0.388 times 448776 plus 0.712 times 469443. Okay, you complete that calculation and it will give you the atomic mass, and that calculation is going to be always the same. It is going to look always the same. Ions differ in the number of, that's electrons. If they differ in the number of neutrons, they are isotopes. If they differ in the number of protons, they are different elements. Okay, and if it differs the neutrons and protons, well, it's kind of the same thing. What species is represented by the following information? So you have 47 protons, okay, and 47, that give you, that's silver. So silver, the 47 would be here. Neutrons, 62 plus 47, that's 9109. That's the mass number, that's what will be here. However, that doesn't really matter. The point is that you have 47 protons and 46 electrons, so you have one excess positive charge, so this is actually silver plus. We actually did this in class. Which ones are molecular formulas but not empirical formulas? If you can simplify, is not an empirical formula. You can simplify this, you can simplify that. Those are the two that we are looking for. And here has to do with what we were working last time. Okay, you locate these elements in the periodic table and you find that manganese is in group 7, which is transition metal. And then you have lead. Lead is in group 14, which is a main group metal. And then selenium. Selenium is in group 16, which is a non-metal. And just so you know, all non-metals are main group, so you don't have to worry about saying anything like transition or non-metal or something like that. So there is nothing related. And this is it. This is the review for exam 1.